Can everybody hear me now? Yeah, can you hear me now? Sure. Going through sound check right now. Can everybody hear me? Real faint. Right, we're working on getting sound ready. Is everybody able to hear? Try it again. Hello? Is everybody able to hear? Those of us who are vertically challenged. All right, is that better? Is everyone able to hear now? Okay. Would either of these be better, do you think? Pretty tangled. They can hear? All right. Well, just in time for us to get the backup mics mostly untangled, I think we're good to go. Thank you all for coming today, and thank you to Julie and Morali for having me. Again, this is Code Smells, how to keep your code from stinking, and we are going to go through just a few of the hundreds of possible scenarios that you could write that would cause your code to perform poorly in SQL Server and what you can do to mitigate. We will be having hands-on demos, which will admittedly be at a smaller scale than what you would see for a production workload. However, I will be giving you some real-life examples that I have seen in the wild, and hopefully we can walk away from this a little better informed. And whatever sphere you come from, if you're a DBA, if you are a developer, if you're a report writer, hopefully all of you come away a little bit better equipped to handle SQL queries. So this is me. I actually do need to change the title. I'm no longer a senior DBA. I run a team of database administrators for a financial investment company in Clayton. I got the lotto ticket many years ago. I was hired straight out of school to be a DBA, so I learned from the ground up and have just never looked back. I've never wanted to get into anything else to this point because I have never been bored doing what I do. I thoroughly love doing my job. So I write in my off time. I write for Simple Talk and SQL Server Central, and I speak at user groups, SQL Saturdays, and I have done a couple of past sessions in the past. So, not a rhetorical question. What do you do? Who's willing to share? Mm-hmm. All right.
forget to thank Doherty.
All right, so we have one person that works with data, primarily Tableau. Oh, there's more. Go. Oh, okay. All right. And today I learned that there is a SQL or a St. Louis Tableau user group. That's awesome. Who else do we have that's willing to share?
I'm shoot. Wow.
Okay, so I don't know how to comment down. I'm Julie Blomquist, the co-chair of the user group, and I'm a database administrator over at SSM Healthcare. I identify the problem queries, but I haven't had time lately to assist in the tuning of them because they're extremely complex. And then we have Ezekiel online, and he is a data analyst.
Right. Right. Anyone else? Yeah. Okay, somebody came over from the developer world. Did you find that you had to take a lot of what you learned and turn it upside down when you got in the SQL Server land, or throw it out? Mm-hmm. Okay. Okay, very good. Anyone else? All right, we've got a wide range of talent in the room, and I'm sure online. I've worked with every version of SQL Server from 2005 up till most recently 2022. Um, and like I said, I've just never looked back. Um, I thoroughly love SQL Server and what it does. So it sounds like we're well enough acquainted with it that I don't have to talk to you too much about what IO or CPU or any of that is, or what a logical read is. Does anybody have a question as to what I'm referring to when I talk about these terms? Because I'm going to be referring to them. Okay. So, story of my life, my query stinks. How do you know if your query stinks? Your queries are slow. Or they started off fast and they got progressively slower as time went on. You get a phone call from somebody like me saying, you're pegging the CPU on the server. Can you tell me a little bit about what you're trying to do so I can help you? Or you're causing a blocking chain that's 12 deep or something like that. When you get a phone call from the DBAs, you know something's happening. Usually what happens when you get the phone call from one of the DBAs, your coworkers start silently sliding away from you, forgetting they know you. But when a problem query comes to the surface and it's either you or you were the last one to work on it, trust me, everyone's going to be happy to say you now own this thing. Why is this happening? And that is what we're here to talk about. So let's get right to it. The first one, dedicated to all the parents in the room, bringing it all back. What do I mean when I say bringing it all back? Who wants to call it in the air? What does that mean? Yep. Bringing it back either all the data ever or more of it than what you need. When does this happen? The most frequent time I see this happen is when people write views, right? They want to write them one time. They want to write what I call the one ring view to rule them all. They don't want to have to revisit it. So they put a lot in. I also see it a lot with temporary structures. So we're talking temp tables in particular are guilty of this. People tend to be, for reasons I don't entirely understand, a little bit better with CTEs. And if you've been at it for a while, you may know better than to do that with a table variable, but temp tables really get it. And then they think that somehow indexing it is going to make it better, which it can, or it actually might make it much worse. But in any case, somebody will populate a temp table with 11 billion rows and only actually use 20 of them. And as bad, or if not worse, I have seen people writing production code with select star in it. And I'm going to talk to you and show you how that can actually break your code. On the other hand, not bringing over data locally when you need it can be just as bad. And we're going to talk about scenarios where that happens in the wild as well. So why is it bad? Well, for one thing, bringing over all the data is going to guarantee an index scan, and sometimes multiple index scans, which we'll see in the next hour in a different demo. It can bring back results that you don't expect or are completely inaccurate, which is not the data you want to produce for people to make business decisions on. I think it's probably not necessary to talk about the I/O costs, since all of you seem to have some experience with this, but you are taking server resources that hundreds of other sessions, sometimes thousands if your servers are really busy, could be using. So if you are using linked servers, you're increasing your cross-server activity. I have called this, in some cases, trying to suck a watermelon through a straw, because they have such a big bolus of data that they are trying to import from someplace else, that everything can come to a grinding halt very quickly. And it can be difficult to troubleshoot that one and figure out where it's coming from on a busy production server. So what can you do to fix it? Well, this one's probably one of the easier fixes. You just rewrite your query to bring over what you actually need when you actually need it. And we are going to go with that to our first demo. Right. And let me get over there. Well, now I'm not seeing my SQL Server. Yeah, I did, but when I went to go see it on my home screen, it went away. I may have to work backwards. Well, this is I think this is the second screen. So is it possible to hook this one up? Okay. Well, no, that is gonna be a matrix moment if I try to do that. All right, let me see if I can work backwards, or if we can get this other monitor hooked up. If we can, that would be best. All right, well, we're working on the screen. I'm just gonna get started here. This guy is just going to flush the proc cache for anything using AdventureWorks 2012. To be clear, I'm in SQL Server 2022. I'm using the very old, antiquated AdventureWorks 2012 to show you this is what I'm about to do is backwards compatible to any version that you might be working on. All right. Let's start off by making a nested view. We're going to start off with a basic view that's going to get a bunch of employee information, and I'm going to add a little column of my own to that. And that view goes into production. And another team gets a hold of it and they like it, but they just need to add, you know, a little bit of something, something to make it applicable to them. So they add a few columns to the view. And let's look at what we've got going so far. And you can see the columns are all there, including these extra columns that we added. All's good. And everyone loves it, so they start building code off of that nested view. So they're going to create a procedure that says, you give me an employee ID, and I'm going to give you all the information from that view. And it works. And everything's there. It's all good, except for Team 2 now decides they don't really need all that data, because they went to one of my talks and they were like, you know what, I don't need one of those columns, and it's not good to bring it all back, so I'm going to only bring back what I need. What's going to happen? It's going to break. In the wild, these can get nested very, very deep. And the left hand doesn't know what the right hand's doing. And it's left to the DBA to figure this out and fix it. Heaven help you if there's a nested sprock calling a nested view. What should we have done? Separate view. Separate view. Rather than nesting the way we did. Here. All right. All right, so the fun time when the server crasher query, we had an instance where we were trying to install an application on Dev, and the owner of the application came to us because the entire server crashed once, then it crashed again, and on the third try, he came hat in hand saying, I have no idea what is going on. And so we started looking at it. And the first thing I noticed was a bunch of columns that were not needed. And I said, so can we get rid of some of these columns because they're not showing up in your results set? And he said, yes. So just getting rid of the columns. The starting stats before I did this were 217 million logical reads. CPU was sitting at 129,031 on a little dev server, which was why it kept crashing. It was requiring more compute resources than the server had. So when I trimmed that down, we went from 217 million logical reads to 344,277. CPU went down from 129,000 and change to 1,407 or 1.470. And I mean, we're feeling really good about ourselves right now, right? And one of my colleagues said, hey, it's Deb, for grins and giggles, try an index. We'll take it off, but let's just see what could have been. We applied the index and it went down from 217 million to 71 logical rates. Just from employing a couple of good practices. It broke our hearts to put that index back on, but the truth was the IO and the CPU was a mere fraction of what we had started with. So it was really a vast improvement just by restricting the use of some columns. Another time I was pinged and asked, hey, can you meet with me in 30 minutes about a problem query I have? And I said, yeah, send me the query. The query was like 30-some odd thousand lines long. And my colleague said, oh, print it out for grins and giggles. It was 37 pages, single spaced on the printer. And it was like this Matrix moment, you know, you're looking at all this code and I started thinking about that guy from the Matrix. I said, oh, I don't see code anymore. I see this is a blonde, this is a redhead. That's kind of how I felt looking at this. But the truth was, I mean, aside from a lot of other improvements, the big thing that stood out to me was how much data they were getting from linked servers. And it was way too much data. So the thing we're getting. And then I said, how regularly does this data change? And they were like, oh, twice a day. I said, reliably twice a day? And they said, yes. I said, then why not try using the wide open pipes of SSIS to bring the data to you locally rather than you using a straw to go out and get it? And it made a big difference for this query, just a minor change. Now, you know, would we still use SSIS? This was some years ago, maybe not. But the point was to bring the mountain to you rather than to go to the mountain. For other problems, I've used replication. If they said, no, it's not a big data set, but we've got to have it in real time, and that's why we're using a linked server. You might argue that replication uses a linked server, however, it's a dedicated linked server. Nothing else is going across that thing. So that can be a better solution as well. Or you could, if you have good developers, you can write your own homegrown solution to port that data over. All right. Views, calling views, calling views, calling views, calling views. Calling tables. We kind of covered this in the demo, so I'm going to switch demos on you. I was working backwards. We'll do the bring it all back thing this time when we get to the demo piece. So nested code, I think we've talked a little bit about this. It usually happens very organically with the best of intentions, and it's fine until it isn't. So let me see if I can, and I do apologize for that. So we're going to switch demos here. Well, we're going to try. Let's see. There it goes. All right. Since we already did the nested code one, we'll go back to the first one. Flush the cache again. And turn on some execution. All right, select all. I wanted to show you guys, we'll start simple and go a little more complex. All right. Here we go. There we go. All right, so you can see here, it's doing exactly what we expected to do. It's reading absolutely every row in the table, which for AdventureWorks is not too bad. But if you think about a production environment, I manage tables with over 1 billion rows. Imagine that being queried by hundreds of people trying to get their reports, so hundreds of times in an hour. That becomes quickly a very bad scenario. But if you only got what you needed, you go from what, 12,000 to 51, just because you didn't get a bunch of stuff you didn't need. And again, scale this out and think about what that looks like to your infrastructure people and your DBAs who are managing a server for, again, sometimes thousands of sessions. It's not like Excel, where if you share a workbook and it crashes, just you and that other person are out. Server crashes, everybody's out. All right, so I'm going to create a procedure that's written, and this is hyperbole to make a point. But I have seen the E dot star before in stored procedures, in production, and it's not really needed. You're the developer that inherits this code, or you're the DBA, and you go to look at this and you're like, where do I even start? Data is, there's too much of it. Some of it's repetitive. What do you even want me to do with this? Whereas, if you had filtered in the first place, you would have been much better off. Select star and views can cause a real problem. So we're going to create a table, and we're going to put some values in it. And I'm going to write a view. I'm going to show you what's there. There's our little table. We're going to put a view on top of this guy. Just a very simple view. And it's not going to look any different to start with from my basic select. All right, now I'm going to put a new column in that table. What happens when I select from that view? Does anyone know? No column. Why? The reason why is the first time you executed that view, it was essentially cached. SQL Server knows about column 1 in that view. It does not know about column 2, so it can't bring it back for you. What you have to do you either have to drop it and recreate it, or if you're on good terms with your DBA, you can tell them to refresh the metadata in the view. And this time, you'll see the column. Now, what about if I drop that column? Now what happens when I select from that view? It's still going to break? Okay. Okay, you think it's still cached? Okay. It breaks. because both of you are kind of right. It knows to go look for that column, but there's no data to bring to that column. So that's why you get that. And again, if you're on good terms with your DBA and you say, can you do me a favor and refresh that again for me? Then you could go back there and the column's gone. Any questions on that? On why select star, bringing it all back is bad, and how to fix it, or nested code? All right. Get rid of those guys. The fun time when this is server for nested code. We had a very fun time when a developer who had an app in dev was not returning the results he expected. He found that there was a nested view call that was using a linked server that hit a completely different environment. This thing was getting ready to go to prod. It was one of the final tests, and he was not understanding the results. Turned out it was hitting a pre-prod environment. If he had not done that test, the wrong business decisions might have been made. It's that's the application that wasn't hitting dev. The 7-layer cake situation, not long after I started as a DBA, I think I'd been a DBA for a month, we had a view break. And I was asked to figure it out. I think I'd been, like I said, maybe a month. It went 7 layers deep. And I had to parse every synonym in every one of these views to figure out the breaking point. And it was that day when I asked myself, did I really want to do this with my life? Until I found it and felt like a hero and said, yes, I do. But it's a problem. I don't necessarily have a problem with nesting a sprock. If you do it right, I think Kimberly Tripp does a wonderful job of demoing how you can use conditional logic in sprocs to call other stored procedures and how SQL Server will optimize that to actually help you. If you ever want to look it up, it's called optimizing stored procedures the right way. That I don't mind so much, but never more than 2 layers deep. Keep it very simple, because the more complicated your code gets, the more brittle it gets. All right, row by agonizing. So to speak to the reason I chose this, SQL Server is batch based. That's what it wants to do. It wants to get you entire bales of hay. It will get you every single straw if you tell it to, whether you intentionally told it to or not. But it's going to take a while, and it is going to cost you. In the DBA community, we call this RBAR, row by agonizing row. When does this happen? This is one of the big forking points, because if you come to SQL Server from a developer point of view, you're taught that cursors are good, functions are your friend, and code should be portable. And that is absolutely true at the application layer. For SQL Server, it can cause some problems, but there are ways that you can help it. Scalar valued functions, or any function on the column side of the operator, is the devil. It will absolutely go RBAR each and every time. And the more rows you have, the longer you will wait for it. Left outer joins. Sometimes this can't be avoided. Sometimes you really do need that sort of conditional logic, but limit it where you can. Implicit conversions. And if you guys don't know what implicit conversions are, we're going to cover it before too much longer here. Missing indexes. And SQL Server can be incredibly selective on which indexes it uses. Again, if you have indexes out there and you don't understand why they're being used, or SQL Server keeps telling you that something's missing and you're not making it work in a way that the optimizer can understand. Again, Kimberly Tripp does a series on the tipping point that explains in terms of math how SQL Server decides how to use an index, and it's incredibly helpful. Like with wildcards on either side. It deals best with the wildcard on the right-hand side. It can deal with the left-hand side. You put it on both sides, and you're guaranteeing yourself an index scan, and maybe more than one. Order by. This is one of the first things I tackle if I'm helping with the query. If I can get Tableau or Excel or SSRS or whatever the application is to order it, I would far rather have them deal with the ordering than SQL Server. I'd rather just serve up the data, right? So it's tempting to use order by, but if you can avoid it, you're better off. Mhm. Absolutely. The gentleman just said he in his user group, they tell the Tableau writers to let Tableau handle the ordering, and that is absolutely the right thing to do. It's gonna, so yes and yes. It will cause row by row, and depending on the size of your table and or the number of times that query is getting executed, that could get really, really bad. You also don't want to set the precedence and think, well, it's just a small scan. It's not a big deal this time, because then everybody just kind of starts doing it. But yeah, for both reasons. Not only what it's doing individually, but what it's doing to the server. Yeah, then you have to see where else you can optimize. I mean, at the end of the day, we're there to provide data to the users in a usable form, and sometimes you have to make hard decisions, which is why I said, if you can, you're better off. But I hear you. SSRS in particular, you're trying to scroll a 30-page report. There's no report pagination. That gets difficult to read. So why it's bad: table scans, and sometimes multiple times, and we're getting ready to see this in a demo. Also, the execution plans can lie to you about how bad this really gets. What to do: rewrite your scalar valued functions as a table valued function. That's a table valued function will execute once per query. Scalar valued function executes once per row. So, you may think, well, there's only 10 rows in my table. Maybe that's not such a big deal, but think about millions of rows, or some of the tables I manage that are billions of rows. That's a big problem. Limit your left outer joins. Don't make them your default. If you need them, use them, but try to keep it reasonable. Watch out for implicit conversions, which again, like I said, we're going to get to that in just a little bit, but that will absolutely cause this. And limit your double wildcard expressions. finally, put your functions like get date and date add on the correct side of the operator and look at missing indexes, but do not necessarily take SQL Server's word for it. There are times SQL Server will swear up and down in an execution plan. This query would be improved 99% if you did this. And maybe it will. Maybe you'll get more performance out of it if you include some columns that it didn't ask for, or refine your key columns that it's searching on, right? So other times it'll say, you'll get the green letters that says, missing index, create clustered index, and it would be improved 40 times if you did this, or 40%. And if you go into the XML, you'll see that was just the first missing index that it recommended. Underneath it was one that would have been much better. So there are nuances to this. You really want to search it through and test it. Uh-huh. Yeah. Mm. We have not done the inlineable table valued functions yet, so I don't want to speak as if I know the answer to that question. That's a good one, though. I will tell you, in the versions that we work with the most, we have told people that inlining the logic is a good alternative. So I think it would stand to reason that is simply a guess on my part. Yeah, yeah. Mhm. Yeah. So, I mean, you can get pretty close. Glenberry has a set of diagnostic queries, and one of them looks for missing indexes, which is we have found to be pretty good. But I think it's always a collaboration between you and the person who uses the data the most, because they're going to know what the data looks like that they're trying to retrieve. We usually work with those people and say, hey, look, if we told SQL Server to search on this column and this column and just maybe bring along a couple of others for the ride, does that sound right to you? And they may not know all the technology, but they can say, yeah, that's usually the data I'm looking for the most. And so we can try it on their local instance and see what the performance boost might be for that. That's I think that's one of the ways you get closer. But again, I mean, SQL Server is basing its recommendations on the statistics on the tables, right? Which may be up to date, may not be up to date. It could be that the queries have changed, so it's looking for different things, or you could have parameter sniffing or any number of things, which is why I think a collaboration makes sense. But in the end, when you are looking at indexes, you are looking at creating the indexes that will support the greatest number of queries. So I don't like, for instance, putting 20 indexes on a table to cover every foreign key that might reference it, right? I don't like that because it takes up a lot of space. It's a lot of maintenance time, so your downtime windows, and it can be a performance killer when you get to writing data into those tables. Now it's got to write to every one of those indexes. So the sweet spot seems to be, over the years, I would say 5 to 7 indexes per table. And then if you find outside of that, that, maybe there's a query that you run once a month or once a quarter, but boy, when you run it, it's a killer and you need to support that query, then I think it makes sense to add another index or two. But I like the broad-based approach better, and we've seen better results from it. Does that help? I know for architects, you really do. There's no way around testing and doing the work. No. Yeah. Mhm. Yeah, you can. And Tableau tends to get different execution plans just because of the way it processes the data. So I think you have to treat Tableau a little differently than you would treat, application queries and or date, maybe somebody has an Excel macro that they're using against a database, or even I've seen people use access front ends. So you really have to tailor it to the situation, but the dream, the optimal thing is to work hand in glove with your developers and cultivate that relationship so they know that they can come to you and you're there to help. You bet. Uh-huh. Oh, yeah. Mhm. I don't know of white papers. I'm speaking from experience, where I have seen as many as 27 indexes on a table. And I know what that performance looks like, especially in terms of maintenance and space and rights versus, similarly sized tables that are indexed more appropriately. Mhm. Right. Yeah. And so it's a trade-off. And I mean, I don't think there's a hard and fast rule for how many indexes to put on a table. It's really, you could have a table that would be appropriately indexed at, a clustered index and maybe one non-clustered. And then there's another table that has a number of use cases that may have 5, and then maybe you have a larger one that gets hit like I described, at month end or quarter end or year end. And boy, when those queries fire off, everything wants to come to a grinding halt. So you throw covering indexes for just that query on there, and you take that hit because you know that it's worth it. Or maybe you just disable the index until that time of year and then rebuild it on the weekend before. There's a number of different ways you could go about this. Any other questions on that before we go to, I think we're going to go to functions. Yeah. Mhm. Yeah. Oh boy, do you know how to ask the question. So this is a subject of big debate in the SQL Server community. There are those who say, so sorry. There are those who say that that you should never do it. It doesn't make a difference. I know of at least one big name in the community that says don't bother with maintenance. You know, you don't need to. Oh yeah, you don't need to do that on your indexes. Don't worry about it. It's just gonna get fragmented anyway. It's just what it is. And then there are other people. I think Kimberly Tripp falls in this line, and I consider her the queen of all indexing. So I always side with Kimberly, who says that you should do it regularly. What does regularly look like? I mean, if you had the bandwidth to do it every night, awesome. If you have bigger databases, I mean, you're over terabyte or you're in several terabytes, that might that might take a very different form. That might be once a week, twice a week with, and when you get to that size data, there for the big queries that just bring the whole thing to a grinding halt, a lot of times we'll tell people incorporate and update statistics into your workflow for that. Yeah. Mm-hmm. Yep, to keep. Yeah. Yeah. I'm trying to get my. Yeah, absolutely. So a lot of times you have, or at least in the occasions I've seen, you have things called workflows, whether that takes the form of an agent job, whether you have software that will do this, whether you use SSIS, they all have the concept of a workflow. So you do task one, and if that succeeds, you go to task two, which may go to task three, no matter whether it succeeds or fails. Before people get in to query, so a lot of times, not always, but a lot of times, when you get toward the end of the job, we'll just say put in a step to update statistics surgically on the table or tables in question, rather than the entire database, which, if you're that big, it's going to take more time than what the business has to sit around and wait. So that's what I'm talking about doing, versus say running Ola, running Ola Hallengren's index optimize every night. If you're able to do that, that's the dream. Live it for me. But once your data starts getting really big, you may have to get a little more creative with it. Mhm. Mhm. Yeah, and I mean too, if and this is conditional, but if you're running OLA and OLA rebuilds your indexes, he's updated your stats. So extra little perk. So any other questions? Right, right. Yeah. Yes. Yeah. Do we have any other questions? All right, let's talk functions. Oh, maybe not. Try it again. All right, so the first thing I'm going to do is I'm going to create what's called a covering index for the query I'm getting ready to run. This is going to be for a scalar function. I'm creating this so that SQL Server has absolutely no excuse not to use it. And then, all right, turn on the execution plans, and I'm going to create a and then I'm going to do a query. And we're using functions in this query, on both sides of the operator here. And it seems like it runs fine, except it's going to look for absolutely every single row. And the reason it's doing that is because the functions are not on the correct side of the operator. In this case, a simple rewrite is all you need. We're going to put the function on the right side of the operator. And voila. Roughly a little over a tenth of the reads. Just with a simple rewrite. Here's our scalar function that I'm going to write. This highly contrived function says, you give me an employee and I will tell you the most money he's ever made, because I'm getting ready to go into end of year contract negotiations. And put this on. And I'm going to do a bad thing. Nobody tell Grant Fritchie on me. But I'm doing this for a good reason. I'm going to run a profiler trace while I do this, because execution plans can lie to you about how bad this stuff is. So I'm going to query that scalar function I just did. And the execution plan is going to say it did 316 reads. But that's not true, because if I get over here, let me see, do I have my reads on there? There's my reads. There it is. It actually read 678. So it read that table roughly 2.5 times. Well, so frustrating. And why did it do that? Well, wants to get the data, wants to calculate it, and under the covers processing. But you would have never known it if you hadn't traced it. But now if you rewrite this as a table value function, and it's not a hard rewrite. I will give all these scripts, by the way, to Julie, so if anyone that wants to try this on their own can do it. And now we select from that, and the execution plan is going to say 316. And here it's going to say, well, at one point, oh, that was when I created the function at 52. Which is kind of crazy when you think about it. This is why we really ask anyone writing TSQL at our enterprise, write it as a table valued function or inline the logic. You know, I haven't done it in years. It might have. Here, let's find out. Why not? Yeah, it's. All right, let's try. No. Yeah, but I selected the scalar valued function. It should have said over 600. Right? It's in defense of SQL Server for this, it is really hard to write for every possible use case. When I was a very little girl, my grandpa once told my mother, "You have 1,000 things to do. She has one. They have 1,000 things to do. We have one. Figure out how to break it." All right. All right, so the day the application died, we had an application that was architected such that people had to write some very, very convoluted functions to get at it. It was just a perfect storm, and it kind of got steadily worse over time. It's kind of like putting the frog in the cold pot of water. You know, we're yelling, "Hey, it's getting worse, it's getting worse," but everyone had a backlog. People do, right? And then one day, the data reached a tipping point, and stuff started intermittently crashing. And at that point, backlog's got to go away. The rewrite must happen. Hopefully, not enough time's gone by that there's nested code that's now dependent on this function, because let's face it, that's what functions are for. It's something that you'd like to avoid getting into, and if you are in that situation, to get out of before it becomes a real problem. All right, inappropriate use of temporary structures. I want to preface this by saying, this is a table variable on a million rows of data. This used to be much worse. If you were in, I think it's SQL Server 2016 and under, and some of you may still be, you've got to be very, very careful with table variables. You get some help with it now. We'll talk about that a little bit coming up, but you have options of temporary structures, and that is a good thing, and that is a bad thing. So when does this happen? All the time. All the time. And a lot of times it happens because you get used to working with one. You get very familiar with temp tables, and you love temp tables because, you know, under the right circumstances, you can index them. It'll honor its statistics. It helps you out. It's a beautiful thing. Or maybe you've done a lot of SSIS work in the past and you're used to working with table variables, and that's just where you live. Or someone taught you how to stack a CTE and you never looked back. But the point is to use the right tool for the right purpose. The reason this is bad is because it can cause terrible execution plans. It can cause memory grants that will make your PLE do a belly flop on the floor of your server room. And if you don't know what PLE is, it's called page life expectancy, and it's how long basically a page will stay in cache before it gets flushed out. You want the pages to stay in cache for as long as possible. But if you've got a lot of churn, and that's what we call it, when stuff is just rotating in and out and in and out, that's a problem. The worst part is you can rack up a big memory grant for a query and it might not even get used, but nothing else is using it because it's been allocated to you. So everything kind of waits, and it waits for no good purpose. In the worst case scenario, and I've seen it happen, it'll fill your temp DB. You do not want to be in the position of having to restart an instance in the middle of a workday. Now you've lost your proc cache. Everything's going to be slow because your procedure cache is slow, and SQL Server is having to compile a new execution plan for everything you just put in that it used to just have on hand. So this can really be bad, but it is entirely preventable. So we're going to go through the options and when to use them. The thing I'm going to say here before we get into it is what I said about indexing. There is no way around testing. You can say, oh, this temp table is going to work, and you might be right, but you're not going to know until you test it. All right, so let's get rid of this guy. Yeah. All right, so years ago, I was asked to write a query to get all the tables on an instance that were 5,000 rows and over for some optimization work we were going to do. I'm going to use that to start with because there is a principle that I want to give. It's very, very simple. It's called filter early rather than late. Okay. Kind of akin to bringing it all back. If you can spare the work that SQL Server has to do to bring that data over, you're doing yourself a favor. So for this one, I am not going to filter early. I am just going to say, go throughout this whole instance, and there's not a lot there. I'll show you in a minute. All right, written in the old 2012 syntax because I'm on a 2012. All right. So it's saying, let's see, where's my, there it is. It's only got a few databases to go through, and it's grabbing everything over 5,000 rows, right? Do not do what I'm about to do at work. Do this in a do this at home with the scripts. You could use Century One Plan Explorer too. This is a little faster. All right. This does not seem like a lot until I filter. Okay, so this time, same thing. The difference is I'm going to go through, and this time I'm going to filter before the insert to the temp table. All right, there we go. 354 and 996 versus. And that's a simple query just by filtering early. Imagine if you were dealing with, and I've seen it, millions of rows, where they inserted all the rows into the temp table and then filtered after the fact. It's an easy thing to do when you're writing, but it's not very helpful. All right, so again, in 2012 mode, you can try this in other modes and I will explain the difference. I'm going to make a table variable and I'm going to populate it with 50 values. And then I'm going to say, give me the top 40 or the bottom 40. If you're in 2016 and under, SQL Server is always going to assume 1 row, which may not be bad if your table variable has 5 rows in it, but may be disastrous if it has a million. Because when it goes to run, it's going to go, whoops. You get some help with this from 2019 on. Microsoft put in, essentially, they use parameter sniffing for good, right? So the first time you execute this, it will make an accurate execution plan based on what the row count was. If you do it again and you use a different row set, it will still count on that first row return as what you're going to get the next time, but it learns. Each time it does it, it gets a little bit better at it until it kind of hits a medium point. So you do get help with it, but it's not as good as a temp table in this case. So again, same logic, temp table style. I'm even going to create an index on it because why not? For the table variable, So it depends on how long I think it stays in cache. It starts to get a little beyond my, I haven't taken it real deep. So if somebody knows otherwise, please speak up. But as long as it stays in cache, it should. In this case, we're going to go down. It makes an accurate row estimate. Took a little longer, in part because I indexed it. Or you could do a CTE. And I'm going to create a table in order to show this. So you can see apples to apples, same value. And that is lightning fast. The reason, it just has to stage and present the data. It's not having to load the data into a table. It's not, unlike a table variable, it's not having to necessarily use all of those features to help you out. It just stages and presents. A CTE is not always your best friend. In this case, it was. They're really good for instances like this. If you just need to hit it one time, CTE can be a great option for you. If you need to hit it more than once, I don't like stacking them. If I can avoid it, I would prefer a temp table at that point. There are times you may actually need to use a table variable. The point is understanding what you're about to use and why you're about to use it and testing it. Questions there? If you need the data to survive a transaction rollback, table variable is a good choice. If you're still doing a lot of SSIS work, table variable is a real solid choice. Otherwise, maybe not. All right. The last one, implicit conversions. Who knows what an implicit conversion is? All right. So yeah. Yeah, so yeah, you're absolutely right. When you give, whether you meant to or not, SQL Server two values to compare, and you didn't tell it that it's two values, SQL Server says, that's okay. I'll figure it out for you. And you can sit there and possibly read War and Peace and knock a couple things off your bucket list while I figure that out for you. These are the ghosts in the code smells universe. They are hard to find. An execution plan will not always tell you this right out. I'm going to demo that for you. Generally, you have two different data types that you're using on a join or on an operator. This is equal to this, but it isn't apples to apples, whether you know it or not. Okay, and it can get pretty nitpicky, but have very, very different consequences. Maybe you didn't distinguish between a varchar and an in-varchar in your code, right? Or maybe you have two different tables with the same column name, but they're two different data types. Why is this bad? Well, SQL Server's having to figure it out for you. That means it's having to think. Anytime SQL Server has to think, the CPU goes up. In the worst case, it can take down your instance if it's bad enough. But you're guaranteed an in-text scan. because it's going to have to make that conversion on every row of data, right? I'm going to show you where you can get unexpected or wrong results from an implicit conversion. And the cure is simply to check for implicit conversions before you push to prod and do the conversions yourself in the form of a cast or a convert. I think cast is still supported, so, or at least we use it. Mhm. Mhm. There's a performance difference if you do it versus it having to do it. And there can be a results difference, which I'm going to show you. Okay. Once again, we're going to flush the cache. And all right, we're going to do a simple query from the AdventureWorks database. This is one of those standard demos for implicit conversions. And it works, right? Data comes across, all appears to be correct. I haven't showed you yet, but I will. So you see the index scan, right? When you go here, it says type conversion and expression, human resources employee, national ID number, right? That's the problem. It's telling you that there is an issue with the employee column. So, or with this guy in the employee table. So if we go to the employee table, where are we? Thank you. I'm getting better at working backwards. No, you're good. You're good. All right. And national ID number is an NVARCAR 15, but we wrote it as an integer. So there's your implicit conversion right there. The fix, in this case, is to write it out as an NVARCAR. And when we do it that way, now you don't have the scan anymore, nor do you have the warning. So you actually get a better execution plan, and your yellow bangs go away, and everything is much happier. Be thinking about all of this, by the way, not only in terms of what it's doing to SQL Server, but if you're in the cloud, think about the costs of bringing it all back. Think about the costs of implicit conversions and functions that are written incorrectly and stuff. This stuff piles up fast. All right, here's another one. NVARCAR, we were talking about this. Well, shoot, that looks all right, doesn't it? But watch this. I go into the XML, and I type implicit. Oh, right. There it is. Didn't show you in the execution plan. Remember I told you sometimes it doesn't? Sometimes you have to go into here to find it. The fix fix would be just to type it correctly, and that disappears. Here's a few times when it's going to bring you the wrong data. Now, if you work in the medical industry or if you work in finance, this is going to speak to you. Imagine making a business decision where you cut 89 cents off of every dollar. Or identification data. Or date data. Again, in any industry that requires precision, you have a problem. Did that answer your questions? Or
So, in the client, your stuff, it's kind of really loaded and I'm kind of going back one. Optimizer is do a once conversion. It's choosing to do the row by row conversion. And it's in return, it's kind of trick or treating instead of.
yeah.
Now I'm curious to see if other database engines have that. We don't absolutely have the ability to do the number two cursor on a therapeutic script. It's the same thing. Driven by the data type stuff. Yes, the knowledge is there on that curve. Could be the right hand side once instead of left hand side once to the right. So, look at this. What to do, like,
Yeah.
so, you can only touch in one row. So when you see with the query, the customer number is looking for the optimizer can look at that and say, I can either respond two ways. I can work the right hand side once as vertical, or I can work left hand side once for the row. And it's choosing to do the second, which has to be which cannot. This is supposed to declare the same. It's not supposed to be, I think that's first. There are for example, where we have a SQL way we compare with what they have regular part. The application of this correct. It has to be more about that. It ends up back to that way. However, that on a Windows way, it will be that for right hand side one so that given its law, incorrectly what I'm saying is that it's the one thirty with strange and different comparison. Because we look at it, we logically know that is insert and that is string column. We need to optimize that way. The optimizer knows that same information at that same time. We've already had the information that we have. It's going to find it that sort of language. It knows what it needs to do. It should be doing it differently. Not be,
The row by row way of doing it.
Not like thinking, oh, I have to do the left hand side first. It can interpret. And it knows it's going to try you know that 001 is equal to 1. Now we do string comparison. example, it still comes up with the answer. Because it still does the same question, just does it 1,000 times, 1,000 rows instead of one time a day. It still does the work, but how can it feel once it doesn't know? It does the comparison, it does the work, still in the theory. A good design. But it does it 1,000 times, 1,000 rows instead of once a day. We know that you were once a day. We have the same information. And it's still coming up with the same answer. And so, my point is, the whole thing is, you're saying it, and I agree, given this thing with the fine, it's not working to it. But it's just slow to the left. And I mean, we're going to got offline. But my point is that, zero to one will be no way to do it anymore. The only way to do that, that is 20,000. What I have to do is put the one out of the for all of them to be zero. It has to do that for everyone. You're saying because it's comparable, it's a very funny comparison to that time. That part of it is on the fine. On that was just converted to on a decent point. Yeah, I'm like, similar to the same time. It's the more about it. So like, get the flight also. Otherwise, it's a really way to do it. Yeah, but that's just
Was it? That was a good discussion. That's actually what I liked